Hey, I'm actually talking to you from the future where I just finished solving the puzzle. Just to let you know, this video is kind of all over the place. I had to take a lot of breaks, I had stuff to do, so I took breaks and I got distracted a lot. So it's a long video and also a really hard puzzle. So sorry that the quality is a bit worse than other days, but hey, enjoy me struggling for about 2 hours. Alright, day 10. Pipe maze. You use the hand glider to ride, yep, okay. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labelled hot springs, pointing in a seemingly consistent direction. Maybe you should find someone. Yep. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some meadow grass, you notice something metallic. Scurry away in your peripheral vision and jump into a big pipe. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver color as the ground. Okay. So we have pipes. So an L is a 90-degree bend connecting north to east. Dot is ground. There is no pipe in this tile. S is the starting position. Okay, so we have dots and then a couple of pipes. Fortunately, there are also some pipes that aren't connected to the loop. So there's a loop. Yeah, this creates a loop. So for example, this one is just the same as the one above, it looks like, but with a bunch of other pipes. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S. So we would have to go S goes down. Which one's the J? The J is 90-degree bend connecting north to west. Oh, so we go in here and then go up. Okay. So this connects that, this, and then it goes here, up, yep. Cool. So if you want to get out ahead of the animals, you should find that tile in the loop that is farthest from the starting position, because the animal is in a pipe. It doesn't make sense to measure this by direct distance. Instead, you need to find a tile that would make the longest number of steps. So 4, if we go for that to that tile, and the farthest point from the start is 4 steps away. Here is the more complex loop again. Alright, find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? Okay, so I'm thinking, even do we really need to figure out what the loop is? Can't we just put this in a grid and go from there? Maybe if the start can be connected to multiple, that would be annoying. Let's have a look at our input. Where is S? There's a single S here, and it looks like it can only be connected to the left and the top there. That is huge, isn't it? Look at that. Wow. But okay, not terrible. Cool. So we take the input and we can make like a grid with these tiles, and I think what I will do is actually pad the input. So last time I think it was day 3, we did a grid problem and we didn't do a great job at making real data structures, so I just did a really bad algorithm. So I think I'm gonna have a struct of some kind, grid, which is equal to struct that has grid, and you're going to be of type array of let's say usize. No, u16 is probably fine. Yep. Okay. We're gonna actually make this comp time, but no need. It's okay. And here what we do is we have make a function that is grid create grid. Just gonna take in our input const u8. It's gonna output a pointer to grid. Here what we do, grid star, yeah, that's it. What we do is we add one empty row, process, add another empty row. So what we do, and we also add left plus right. So first of all, let's take in an allocator, which is of type standard.e.allocator. Okay. And we're gonna allocate. Grid rows equals try allocator. Oh, and this needs to exclamation marks. It can throw an error. Allocator dot alloc. It's gonna alloc u 16, u16, and of size input dot length plus 2. So top and bottom. Yes. Yeah, I think that's right. Standard.mem.zeros. Generally user encouraged to explicitly initialize all values. Okay, but for each one of these, there's actually an array of u16 for grid rows, row is equal to, actually we should probably use indexes here, 0.grid rows.length grid rows at index is equal to try allocator dot alloc u16, and you're going to be input 0 dot length plus 2 left and right. So grid rows at I 0 is equal to 0. Grid rows at I input 0 dot length. Usually you'd go -1, but in this case no. There we go. And then in between, what we're gonna do is I'm actually gonna ask if I is equal to 0. It's like quite inefficient to do this way, but it's okay. If I is equal to grid rows dot length, so then we continue. Otherwise, we're actually going to allocate to what the input is. Okay, let's make a couple of constants based on these. Here we are. So const north vertical underscore pipe is equal to that. Const horizontal underscore pipe is equal to this. Const north underscore east. We can probably just say north east is equal to L const north west Right, northwest. Northwest, northeast, yeah. East, south, west. Yep. Const, south, east, and const just empty. And then the S is the start. Alright, we have a couple of values there. They act as enums. Well, they're not actually enums because they're not types. Here we go. Let's continue. Alright, down here we're going to go grid rows at I. Oh, here we don't. We can continue, but standard.mem.zeros we can set to 0. The the entirety of grid rows I, and we can put them in the same one now. Nice. Okay, that's not so bad anymore. Okay. We're going to take the line which is input at I, index equal to 1, and we need to go full 0 for line C, index plus equal 1 there. Actually, you can go 1 dot dot 1 dot dot put 0 dot length. That's non-inclusive. Non-inclusive. Oh no, let's just keep index there. So grid rows at I at the index is equal to C. And I think we're going to get U8 here, so actually these would be a lot better as U8s. Oh wait, in that case I don't even need to change input that much. Yeah, no, not at all. That's me complicating things now. All we need is we're gonna need some memcopy because we want to pad it. So we're definitely gonna have that, and we're definitely going to allocate. And let's actually go empty instead here. Otherwise, what we're going to do is standard.mem.copy. U8, the destination is input at I. That's a destination. Destination is grid rows at I. That should have done it. Return the pointer to grid equals grid rows. I think that's fine. And let's do grid equals try create grid var allocator equals standard.heap.page allocator. Print Let's see, is it run? Main. What's the type? Mem.allocator? Might be. Unable to resolve comtime expression. Zeros initialize the type. Zero init. Maybe it's that. Takes in a comp time. An array of U8. Is that what it means? Or just U8? Maybe U8. Okay. Function init zeros. I feel like I've done this before, but it's going to take line. It's going to be a U8. Yep. Void. Let's actually take a pointer to it. For line dot star. No, for 0 dot line dot star dot length. Line dot star. L equals line dot star. God, I'm taking a while doing a lot of this like boilerplate type thing. L at I equals let's do empty. Change there, and it's zeros the pointer. Yeah, U8. What is this? Okay, but like, do I need brackets? Return type, function return type right here. Expected type info, yeah. And then it's the error union, like it's why is that not working? Maybe I need to do var grid equals grid, turn grid, another pointer to grid. Yeah, so seems like something is with there. Oh yeah, grid rows. Oh yeah, we can't directly copy, can we? No, we can copy from one dot grid rows at I dot length -1. That could work. Okay, let's do it in a for loop, I guess then. For input C, no, input I, C, grid rows, index, usize plus 1, index is equal to C, index is equal to 1. Okay. Come on. This is non-inclusive, so we should be going into here. it maybe +1. So 1, 2, 3, 4, 5. You make 6. No, I definitely want to make 7, right? Again, this is not the type. This is not the issue I should be worried about. Well, not +7, just +2. Yeah, it gives you 7. Go through this. So at 5, just skip the I. Oh, this should always be lagging behind 1, right? Yeah, should lag behind 1. Okay, we're going to do print.grid.grid. Okay, let's do an S there. Dot dot. That's wrong there. Then it does S, the pipes, this. Oh no, it's not wrong. There's padding. Yeah, that's what matters. And then there's dot dot S dash 7 dot comma. So actually, actually, this should be a +1. Yeah, no, now that's right. Cool. Okay, finally, God, we have a grid. And what we have to do is go from the start, look around, and see where we can go. So we're going to have an index, x, which is going to be usize for convenience, and then y. So it's going to be initialized s, and then it's going to be a move. And there's if you're at a pipe, you should see 2 connected. And you see 2 connected, but you don't want to go the same way that you came in. Type function walk. I'm wondering what this could be. How did I do this in other days? No, not there. Is it day 7? Day 6? Somewhere, yeah, here. Self. Oh, yeah, self is of type grid. I think you can do self, which is add this for your convenience. Because this returns a type. Yeah, you can do this. Sure. And self dot. No, let's not worry about that. Let's do grid. And also now, yeah, we'll worry about where you came from. We can probably store that in self. Last x, usize. Last y, usize. So then we can check if we want to move. And if that would put us back where we came from, then don't move. Also, this would go on forever, so I need to be careful with it. And also, there's the fact that you need to go both ways. Here to there, to there, to there, to there, to there, to there, to there. But yeah, we'll figure out those edge cases later. So, so I guess we could have like 2 grids eventually. Yeah. Okay. So walk. 4 0.2 I 4 0.2. It's going to go 0 1. Oh yeah, non-inclusive. We learned that the very hard way. Let's do underscore I. So var v, which is actually I128. which is as I 1 to 8 underscore I, take away 1, and that's I, and then this would be J, yeah. So if I is equal to 0, and J is equal to 0, we continue, otherwise we're just going to keep checking around. If self.grid at, so the x and y's would be the other way around here, because x moves along and that's actually a column, so it's going to be, well, yeah, let's do self dot y plus I. Yep. I think this might complain because yeah, maybe it will complain, but let's see. It's J. If it isn't equal to empty, not equal to empty, we found 1. And an extra check we want to do is if self.y plus I is equal to self.last y, and self.x plus j is equal to self.last x, then actually no, we've just been, so we're going to continue, otherwise here we're going to go there. So yep, so we're going to say self dot last x is equal to self dot x, self dot last y is equal to y, self dot x is equal to yeah, we're going to need some temporary variables. Yeah, var temp x equals self dot x, temp y, self dot y, temp x, temp y. Okay. And in here we can actually return. We'll probably start them off at 0, 0, and it will just choose the first one to go to. Do you compile? You do not. Oh yeah, because now grid has a bunch of stuff missing. Dot last x equals 0, dot last y equals 0, no, last x, and then we can go dot x, position of x equal to use size 0, y, what we're going to do is just do a check. If c is equal to start, x is equal to so x is the column, y is the row, so it's going to be I, and x is equal to 1 dot dot. Okay, it's going to be k, I think. I think that should do it. Let's just print the grid as any. The x equals 2. So yeah, so with the padding that checks out. Good, good. And just to, what we're gonna do as well is gonna print x, y, underscore grid equals underscore grid dot star. So now we don't have to do this all the time. X grid dot y, and we're going to go grid dot walk 3, so 4 times. Expected use size found. Yeah, I thought that would be a problem. I'm not sure what like the best way to do this is. Is it like I don't know. As I128 self dot y as I, and then go back. That seems really weird. Yeah, I don't understand. Unsigned 64-bit int cannot represent all possible values. Truncates, maybe? Truncate. And resize. No, it's not truncate then. It's definitely as at int cost. Convert an integer to another integer while keeping the same numerical value. Return values inferred. Maybe it is int cost. But 128 might not work. Oh, let's take in a pointer so we can do stuff like that. Underscore self var self is equal to underscore self dot star. And when we are altering stuff, we can go underscore self dot star, underscore self dot star, underscore self dot star, underscore self dot star. That is usize, and then j is not int cost as with self as var j usize equal to int cost j I usize. God, I'm spending so much time on stuff that's not actually important. But you know, learning the language as you go. It compiles, but integer costs truncated bits. You sure? I mean, does it matter? So let's see anyway. So we would go 2, 2, 2, 2, 3, 2, 4, 2, 4, 3. Oh, it's working. Then all of a sudden, truncates bits. Zig I128 to E size. Is there like a good way of doing this? Oh god, it's really old documentation. Zigline. Int cost. Is there anything? Int cost. Okay. If you have values on Ninja that cannot goes to type you want, maybe use to explicitly convert that type. As. You know, obviously that works, but is there at int? Oh, unsigned. No. At truncate. Let's truncate J. No. Integer cost truncated bits. Not super sure what this would mean, to be honest. Is it because J is negative here? Oh, true. J could be negative. Yeah, so you don't want to do this. What you do want is you want to go as I128. Did I really say 128? That's so overkill. But but okay. As I128, and we add just J, so it could be a negative. And we go back to as usize. It's probably really inefficient, but so we need to convert, and then we need to convert back. No. Int. What about int cost again? Temp x. Let's do I128. Int cost. I128. Int cost. And hopefully we don't need this anymore. So we can just say temp x, temp y. Oh, it's because this, like say as a use size, maybe we can do int cost again instead of as. I think as is for precision, like U8, U16. Okay, that works. And I mean, we could continue to do this, I think, indefinitely, right? It would just loop around. Yeah. Eventually goes back to 2, 2, 3, 2, 2, 3. Oh no, it seems to get stuck in one of them, so it doesn't know when to. So it goes to 4, 3, 2, 2, 4, 4, 3. Oh, it skips diagonally. We cannot do that, right? Yeah, I can't do that. It needs to go left. Yeah, can't go diagonal. Oh, yeah, that's. Ooh, this code is a little bit wrong. It's quite quite wrong, I suppose. Yeah. So only I and j can be. Oh, like this can be massively simplified, can't it? Yeah. I am silly, but maybe it's useful for part 2. What we'll do is we'll just say if I is equal to 0, I is not equal to 0, and j is not equal to 0. We continue. Yep. So basically, what that does is that would go into diagonal, like 1, 1, or minus 1, 1. Yes, so now this should work, hopefully. So it goes 2, 2, 3, 2, 4, 2, 4, 3, 4, 4, 4, 4, 2, 4. It jumped. Why did it jump? Also, yeah, this is fairly wrong because of we're not actually checking. Are we checking pipes? No, we're not checking anything. This is really silly. Okay, I say we're actually going to start again. Bar up is equal to self dot grid at self dot y minus 1, and then self dot x 2, 3, up, down, left, right. Left, right. Okay. We need to do a current checks. Bar current is equal to self.grid self.y self.x. If current is equal to, we could be a number of things, to be honest. Yeah, the hard one will be start. I think start could yeah, the determining the start is kind of weird. So I'm gonna think of the other ones first. If we are vertical, then we can only go up or down. Up or down, valid. Else if current is equal to horizontal, left or right, valid. Else if current is equal to north, east, up or right, valid. Else if current is equal to northwest, up or left, valid. So if current is equal to south, east, down or right, valid. Else if current is equal to southwest, down or left, valid. Cool. But what about if it starts? If it starts, I think yeah, it needs to figure out which two actually connect to it, which two point to it. Well, let's finish this logic then. And instead of last x or y, we could do last direction. So we came from north, east, blah, something. Const up, 0, down, left, right. Oh, let's do an enum. I've never actually done enums in Zig, so enum. How'd they work? Enums. Cool. Yeah, literally, basically this example. And we could have done the same there, but that's okay. Up. Oh, no. Down, right, left. Last direction, which is a direction. If you are vertical, and if self dot last direction is equal to direction dot up, yeah, you're going to say, and you can return there. Self dot x equals, so if your last direction was up, you're going to go down. So self dot y plus underscore self dot star dot y equal to self dot y plus 1. Minus 1. So now we want these, if we're horizontal, the direction was left. We're going to say x, 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 x. North, we are currently on a northeast, so if we came from up, northeast, yeah, this one, if we came from up, we've got to go right. Going right, it's the same as doing that. Otherwise, we have to go east. No, we have to go up, so this one. That's probably a better way of doing this whole thing, but it's okay. Northeast, if your last direction was up, then you're going to go west. Otherwise, you are going to go north, which is minus 1. Minus 1. Yeah, not, it's kind of the other way around because of, obviously, arrays and stuff. If your last direction was down, then you're going to go east. So you increase your x. Otherwise, you are going to go down, which increases that one there. If your last direction was down, again, you're going to go west, so minus. Otherwise, yeah. Yeah, let's get rid of that big for loop, no need. Just a really big if statement instead. So that should just kind of work. So you're here. We don't really need to check what the next one is. We just know. Hopefully. Maybe. Oh, we haven't done start. Let's go none. Let's do another one here. None. It's going to start at none. And if last direction self dot last direction is equal to direction dot none, we are at start. And here we're going to look for the possible combinations. So if we're here, we look to the right and the bottom, see if they can connect. Oh, that's That's really hard though. How would I do that? Hmm. In this case it would be if bottom is facing up and the right is facing left, then we connect. So it's like these pairs we have to look for right. Yeah, these. That's a big if statement. If current. Now, if. So let's follow this example. So if down is equal to vertical, or down is equal to basically pointing up, north, east, or down is equal to north, west. Down is this. Oh, the brain is really foggy about this. But yeah, we definitely have to do it. Like in other examples. Here, there's the S. We look left, we look right. Yeah, let's just continue this. If the bottom one is facing up, and the bottom one is facing up, then that means that we must connect. You could connect to the bottom one. Yeah, brain is just so foggy. Might go draw this out and see how it turns out. A little bit less brain fog. What we're going to do is just write a couple of helper functions. Oh, yeah, we will do that, but before that, we need to come here and say, if the start can be vertical, if up is equal to vertical and down is equal to vertical, we will say that self dot, do we change the grid? I think we just change current. Yeah, let's change current. Current, and it's not this, let's not do none there, there's no point for that. If current is equal to start, yeah, is equal to vertical. Only one of those will hold, so we don't need to check much else, I think. Yeah, let's do an else if, just in case then. And then left is equal to horizontal, and right is equal to horizontal. Current is equal to this. Else if left is right pointing left, and this one is for the north west, which one was that? The J, right? The J. So if the left side points towards me and is down pointing up, else if, what else do we have? We can have northeast and northeast is when is left pointing the right and is down pointing up. Northeast, which is equal to not the 7 but the L. Yeah. Else if, what else can we have? We move on to the southeast, southwest, and then, yeah. If is right pointing, no, is left pointing the left, and is up pointing down. Else if is right, no, is left pointing the right. This is for south. West. No, for this is right pointing the left, yeah. Is left pointing the right and is up pointing down. South east. Let's check. So is left pointing right? Yep, and is up pointing. Yep. This one is J. And we're just going to do those in just a second. The southwest is the 7. The southeast was the which one was southeast? F. Oh, let's just use the real letters. What am I doing? Vertical. Horizontal. It's going to be a really long video, I can tell. Northwest. Northeast. Southwest. And southeast. And let's just write those functions. Function is right pointing C, which is a U8. Right, ball. Is right pointing, is left pointing, is up pointing, is down pointing. So you are right pointing if C is equal to horizontal, or C is equal to basically just pointing to the right. So north east, or C is equal to south east. And they're very similar statements. They're very similar statements. Is left pointing if it's horizontal, north west, south west. Vertical, north, or the other north is northwest, south west, vertical. Okay, that's a really big if statement. Okay, what did I get wrong? Yep. Now we have to adopt last direction now. Last direction is equal to, let's just say directions dot left or something. It shouldn't matter for that first one. But what should also matter here is to save that last direction. If we are vertical right now. Oh, wait. See what happens. Yeah, we go back and forth. 2, 2, 3, 2, 2, 2, 3. If the current one is vertical, right? We have to come up or down. Do we change anything in this one? Last direction we came from is, if we came from up, we're going to increase. We came from up. Otherwise it came from down. No need there. No need to change here either, I think. But this one I think we do. We do need to. We go, if the last direction was up, like we came up, and now here we go left, so let's go self.star.last direction is equal to direction.left, because that's where we came from. Otherwise we came from up. No, if we came from up we change. If we didn't come from up, we're gonna go here. And we came from down. That's it. God, it's such a long exercise. Okay, northwest. Northwest, so we came from up, and now we're moving left, so left, and then this is up, and that one is up as well, right? The -1 means we are moving up. Yeah, I think I just have to follow exactly the settings here. So here it's right, here it's down. We -1, so oh no, it's all the inverse, isn't it? So those ones don't count. Here we go left because that's the inverse. We're taking away, so we're going down. That was where we came from. Left, right, down, left, increase, came from up. We came from the right side, we came from up. Alright, I think that makes sense in my brain. And I think it makes sense in the program too. Because it goes 4, 2, and then 2, and then, wait, 3, 2. And then it skips. There's a skip. Like what? There's a couple of jumps actually. 2, 2, 2, 3, 2, 4, 3, 4, 4, 4, and then it goes there. That's not alright. Goes up all the way. 4, 2, 3, 2, and then it jumps. Then it jumps again. Oh god. Oh, actually it's because, oh, look at that. We have a couple of walks and we're printing after, which gives us the impression that we're jumping, but we are not jumping. Great. Oh god, so long. Okay, cool. Can you turn it down, please? Wait. Can you turn it down, please? Can you turn it down, please? Still recording. Ooh, so pretty. I'm just nearly done. Nearly done.
Nearly done?
Nearly done.
Maybe you're just dumb.
You're dumb. Alright. Okay. Still recording, so. Now what? Now. Oh, we need to see where we're furthest away. Oh, these fucking wankers, man. Just fuck off with your stupid cunt beeper twat.
I bet it's that guy with the van.
No, it's not. I think it is a van, but it's not that one. Boop, 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 fucking. So now that we have this working, I'm actually going to separate that out into another function to be find start, because then we can alter the last direction to manipulate it to go the other way, because we want to go down both ends to find the longest longest path. Yeah, I think that makes sense. Find start. So self grid returns direction, and this is going to be this big statement basically. Find start. And like only call at the very beginning, because we're just going to assume that, you know, x and y are actually the start. So find, and it's not that, it's going to be u8, which is going to, yeah, I'm doing this like Go style enums, which I shouldn't have done, but it's fine. And I'm going to return current at the end of that. Yeah, we don't need these anymore. Let's make sure we haven't broken anything. Let's make sure we haven't broken anything. Yeah, so that circles back. Cool. And what I'm going to do, start equals grid dot find start, and the start, it will basically tell me what type it is. Oh, there's probably just much better ways to do this. Start if start is equal to, oh, I need this big if statements. Vertical. Yeah, I'm just going to copy it. Today is not a good day for the admin of code, I think. Instead of current, I'm going to say, so let's just delete a bunch of stuff. This can go, this can go. 6 down, 6 up, 7 up, and then dot. What? Maybe too much. North, north, south, south. Oh, we did get rid of start horizontal, else if, yeah. First go is equal to direction dot up. Second go direction dot down. If we are vertical, first go is equal to direction dot up. Second go, we go down. Are we horizontal? First one's going to go left, first left, second one's going to go right. First one's going to go up. So it's north, northeast. Second one's going to go right. Yeah. Left, down, right, down, left. Cool. I'm going to do grid dot last direction is equal to first go, and this just luckily walks the exact right number of steps for this example. Print just big line and new line. Let's not walk at the end there. 2, 2, 3. Yeah, it goes the other way. Great. But we need to do this in a more programmatic way. Start x equals grid dot x. Start y, grid dot y. Grid dot walk once. So we're going to walk once while grid dot x is not equal to start x and grid dot y is not equal to start y. We're going to do grid dot walk. We're going to print. Yeah. And we can get rid of you and copy this. Yep. I think, oh wait, no, that's done something weird. Wait, so it walks and, no, prints once and it walks. That's weird. Oh, it's an or, isn't it? Yeah. It's an or. Cool. Great. And then that's good. Now what we want to do is well, actually, because we're going to loop back, maybe I don't even need to do this twice. For part 1, the size is 0. Let's get rid of these print statements here. We're going to walk once, so it's going to start at 1. And each time you walk, part 1 plus or equal 1. And then you can divide, right? Maybe I don't actually need to do this. We can do print part 1. It's going to be part 1 divided by 2. Maybe we'll get, if it's an even, it's an odd number. Original real part 1, and then part 1, I guess, just in case for us to spot some mistakes. Alright, and that was the very example, so in that case it is 4. Oh, okay, but you know, I think we built like a pretty robust solution here. That is 8. And this would be, is that right? Alright, good. That took fucking forever. But fine. That actually took so long. I don't know. My brain is just not working and operating very slowly today. You quickly reach the furthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. Oh, okay. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. Oh no, oh no. That's just not very nice, I think. So, this and this. This. Oh. Oh, I don't like that. I don't like that. So The above loop encloses merely 4 tiles. The 2 parts dot dot. Oh, yeah, in between the tiles, because this is outside of the loop. Oh no, that's not okay. That's not okay. The middle dot tiles marked O below are not in the loop. In fact, there doesn't even need to be a full tile path to the outside for tiles to count as outside the loop. Squeezing between pipes is also allowed. Wait, I don't understand. Squeezing between tiles is also allowed. In fact, that doesn't even need to be a full tile path to the outside of the loop. To the outside foot tiles to count as outside loop. Squeezing between pipes is also allowed. Not quite sure what that means, to be honest. Here I is still within the loop and O is still outside. Oh, right, because, yeah, see, there basically no surrounding, no need for surrounded dots. Oh, Has many random bits of ground, some of which are in the loop and some of which are outside it. So we're counting dots. We need to look at one perspective dot. I think what we could do is store every coordinate you visit. I mean, you visit a lot, but fine, this is like not even that many. Every coordinate you visit, like encoded, like x plus y or something, like as a string. And then you look if a dot is within that range. So for example, this dot, we look for left, right, up, down coordinates, and we see if we are within that range. Okay, you know what, not terrible. I don't think it's that bad. We have our part 1. I guess we would need to restart it to be... Oh, here it doesn't even matter, right? Part 2 is not about going around the loop. Yeah, we really like built a very complex solution here, I think. There's definitely better ways of doing it, but it's okay, it works. Let's continue. Part 1, now we're going to look for a dot. Let's do that in our grid object. Pub function. Oh, wait. Going to need a map, so actually walk is going to take in a pointer to to a map, yeah, to standard dot auto hash auto string auto hash map. Okay. Between U8 and U8, why not? Oh, actually, star. Now each time we walk, we take our current one. In the edge case there is that you need to account for the start as well. So map dot put, and now this needs to be just throw an error. Try map dot put the key, which needs to be a string. bar chord. Annoying. It's gonna be. Well, I really want to do x plus comma plus y, but obviously can't really do that. Can't really do that. Oh, how would I do this in Zig? Standard dot format dot format int. Just had to take a break there for dinner, so I am completely lost and kind of forget where I am. Yeah, it was this kind of flood filly type thing, but you can't really flood fill unless you expand the resolution. I don't really want to do that. It feels long. Remind me, what do I know? Find start, yep. So I mean, we know the start. We know the start is one of these, and let's take this one. So for this example here, the middle ones are not. As you can see, they have an even number of, so if we go through each dot, I think we iterate through each dot, we count some of these. So if we had an odd number of these to the left, if we had an odd number of these to the left, maybe we would be inside the loop. You see what I mean? Like, if we go the dots here, this is for sure outside, but if we look here to the left, I have an odd number of bars. So that would work, but would it work for stuff like this? Because we have a bunch of like pipes that aren't really connected, so I'm not sure they matter. So maybe I have to kind of ignore the pipes to the left. Either way, it's kind of weird. And then the a southeast and then a west south would cancel out because they would like go down. So like these two would cancel out, like be a plus, a minus for like up and down, and the same for the others. But I'm not really sure that would work. Maybe I am onto something. Let's look at the eyes here. What do we know about the left? So it has this one and that one, therefore those like cancel out. We have this one and this one. Oh no. No, but that doesn't tell me much. It really doesn't. I think the other approach would be to expand some stuff and then do some search. Oh, that's... I don't want to do that. It's really annoying. Yeah, this is a super tricky one. I think I have to think about it for quite a while. Yeah, definitely gonna edit this bit out. So I think that first approach I was just mentioning is correct, but you have to only look for the pipes inside, like that are actually part of your loop. So I'm gonna do some coding, and self is going to take in a pointer to a map, changing a read-only file. Okay. It's gonna take in a map. Yeah. Map, which is a pointer to standard.auto hash map. Oh, how do I encode X and Y in a good way? Not exactly sure. I think I can probably do some string appending of sorts. Oh, that's pretty annoying though. Alright, anyways, yes, it's gonna take const u8, or just u8, and it's going to be to a u8 or something of that type. Okay. And then down here, what we can do, map equals this dot init with the allocator. We can defer allocator dot free the map. Oh no, map dot the init. Okay, but now I need to actually find a way of encoding that stuff. So when we do a walk, we now need to take in the pointer to map, and we need to basically, I need to do self.x plus this plus self.y, and I need to put that in the map. Unused argument in part 1. Oh yeah. What is this? Does not allow slices as well as unions. So u8 is out. Oh god. Oh god. Oh god. Oh god. Oh god. I'm stupid. I'm stupid. Oh, I'm so stupid. I just take. Oh, that's just. I'm so silly. Just take U1 to 8 and then take both of the U sizes. Oh my god. So easy. I'm just. Oh. Wow. Just ignore the last 10 minutes, whatever it was. You are U1 to 8. Brilliant. Double U sizes. And what I'm going to do is I'm going to say as U1 to 8 start X to the bit shifted 64 times and ORed with as U1 to 8 the start of Y. God, that's just, I cannot believe I did not just remember that. You know, that's just really quite sad actually. I don't remember that, but anyways, we learn. Let me find that. Try encoding, just go away. I can just take this and then self.x, self.y. So this is going to take, actually I don't, yeah, this is going to take the very first thing. So I don't need to do this here, I need to do it here. Grid.x, grid.y. It's going to move one last time and I'm not going to catch that last bit. Like this, I can let's see the ucompile. Encoding dot star. Oh yeah, no need for you anymore. Standard of U128. I mean 23, yep. But I also gonna need you to print any of the map. Oh, I mean, yeah, it doesn't show me much, does it? Var iter equals map dot. Do I just assume it's right? Let's just print map dot like the key size count. What do you return? A size, which I think is like a U46. Probably right. That's 1, 2, 3, 4, 5, 6, 7, and then 14 on the other side. 1, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 45, 46. That must be it, right? 46. How many non-dots are in here? You know, I'm actually going to take the part 1, just in case. That should be 8. That is 8. Great. That's fine. Now, what we need to do is do some counting. We find the dots. Actually, we can probably do this here. Grid dot grid for grid dot grid row for grid dot for row Oh, we want to iterate. So grid.length I, grid.0.length j. If var if grid at I j is not equal to a empty, we continue. Otherwise, we will actually check count number of various things. So vertical equals outside loop. We want an odd number of these. L and J equals outside loop. We want them to not pair up. We want north to not pair up. And then same for the south. So F and forget what did he use for a 7. Outside loop. So so let's just count a couple things. The number of verticals. We don't really care about the horizontals to the left, but then it could be a case that we have something like vertical, an F, and then oh no, if that is definitely part of the loop, and we're here, yeah, that's for sure out, right? Because it goes through both, so it cannot be. Yeah, I think if that first condition is true, it's just out. So what we're gonna do is we're gonna count left. We're gonna for 0.j plus 1. So we want to. Do we want to include j? Oh no, it doesn't really matter because j is a dot. So j that's like guaranteed to be a dot. K. So it's k. So what you can do, you can say encoding. Just gonna say e, which is like this here. You're going to take as the x value k, but as the y value you're going to take I. Yeah. Cool. Oh wait, I need to remember. So the x comes first. So the k is the one moving along. Yeah, that's fine. Cool. Oh, that's cool. Counter. Let's just go with. What did I set it to? The U8. I can't be good. Go U size. We're gonna go U size. Yeah. Just in case. Right, just in case. Let's counter. You are U size. You start at 0. North counter. South counter. If map.get e exists, we know it exists, so now we need to check. If grid at I and k is equal to vertical, then a vertical counter plus or equal 1. Else if, I'm just gonna say A equals grid I. Okay, and then change to there A. Else if A is equal to north, I'm gonna say northwest decreases the counter, so I'm gonna start with northeast. What we want to end up with is with a non-zero number anyways. Ooh, but that means we can have negatives. Okay, that's fine. I128, just in case. I128, I128. So, and we go north counter, northeast increases it. Else if A is equal to northwest, that decreases it. Else if A is equal to southeast, the south counter plus or equal 1. Yank southwest minus equal 1. Okay. So we've counted. And we go. Definitely outside the loop. If vertical counter mod 2 is equal to 0, and do we, like, if I am here, there's got to be like edge cases to do with some of those, with the other ones, right? Or is it really just vertical bar? I'm going to try vertical bar and then think about it a little bit more. So if there is an even number of them, then we can do part 2 plus or equal 1. Would it just be the, yeah, I'm kind of thinking that those vertical bars are kind of it in terms of what you need. 0 dot dot 0 dot dot. Oh, just run. Grid does not support indexing. Yep. Grid. Okay. Vertical counter. Why can't we run this? Oh, grid. Not there. Where is this? 238. Ah. Okay, wait, we're printing some out there. oh, sorry. See, that part 2 is just huge though. Yeah, that's like, it was meant to be 4. How is it that big and literally only increasing you here, which is here? Maybe. Wait, how is that even possible? It needs to be. There's not even that many dots. There's not even that many dots. What? I'm so confused. Empty. Just a dot, yeah. so weird. Count these. How does it reach? Print grid.grid I j. Dot and this. Forty-six. C for character maybe. I mean, my point is that there just doesn't seem like that many. I'm gonna copy it and do this and half it. 70, 35. 92 is ridiculous, like, there's no way. That each time anyways, vertical count is bigger than 1 and that is true. Then part 2 is still huge. But what? But why? But really? Why? Oh, yeah, it's counting like the dots around the edges, you know, because I have the padding. But like, okay, this is counting 2. And I don't really know why it's counting 2. Should only ever count 1. And if we do, let's print adding that, and this is going to be I, j. 3 and 5, which is going to be 2 and 4. 0, 1, 2. 2. Oh, odd number. There's going to be an odd number. So, actually, the vertical counter, this. Now, I get 1. Great. Let's get this example here. We should get 4. We get 5. Yeah, because of what? Where is there a thing? Oh, here. You see? Just to the left. Do I need to count left and right? Because here, no, to left and right we have 4. Oh, odd number to both sides. No, but then this one will still apply. So then the edge case would be if there are any of these present, right? So these ones don't cancel out. Right, so see. And north counter is equal to 0 and south count is equal to 0. I think this would work for this example, but I'm not sure how well it would work for others. Because there might be an edge case that I'm forgetting here. So yeah, that one just goes 0. That one just gets 0. Because I am counting left for the ones that... Also, I am only checking the ones that do exist. Yeah. Let's think. So, I don't really know where the loop is here, to be honest. Where's S? Yep. Up, down. Yep. Just goes around a lot. Yep. Goes definitely around a bunch. But here, these two are connected. Oh, yeah, this is not, it's not just that. Oh, I wonder if this then can be done on by this strategy alone. I'll go think about that for a sec. So I think I figured it out. If you have an L and a 7, like you do there, no, how much you can see. You have an L followed by a 7. That's kind of like a vertical wall. Is there an L? Yeah, so 7, L, 7. So it's as if you just moved along once and came down. So in our solution here, it's not just enough to count this. We're going to have to see that as a vertical wall. But if they are closed like this, kind of need to do it twice. So we're going to keep a last segment, last char, which is equal to empty. And basically, yep, we're gonna check this stuff. If it is vertical, then yeah, we're just gonna increase. If it is northeast, choose northeast again. An L. An L followed by 7. Or in that case an F and then a 7. Yeah, we need to wait for them to like close. So if it's northeast, northeast, which is an L, I think we do nothing. Last chart is equal to grid I. Okay. But if it is northwest J and we came down with an L, we want to like add 2 to the counter. Oh, I'm not sure that makes much sense because you're just going to mod by 2 anyways. Maybe add nothing. But I know for sure here, northeast is the 7? No. Which one's the 7? Southwest. If southwest, if last char, what we don't want to do actually is if it's the dash, if grid.grid I k is equal to horizontal not equal to horizontal. We run that. If last char, if it's a 7 and we came down with an L, north east, then vertical counter plus or equal 1. It's as if we've kind of gone into it. I think we can get rid of these here. Okay. And now, so southwest was 7, opens to the right, and then closes. So if northwest, if we came down with the F and J, so if last char is equal to south east, so we do vertical counter so equal 1. Alright, northeast, and this would be southwest. Does that make sense? Northeast is an L. Southwest. Yeah, that's it. If last char is equal to southwest, vertical counter plus or equal 1. And then there is this one here, which is northwest. So southeast, and then we close it. Yeah. Am I confident? No. No. Oh, promising. That's promising though. It's quite, I think, quite a okay solution maybe. But yeah, there's some that are being counted on this one that are not those ones. So if you are vertical thing, and this for sure exists, then we're gonna add 1 to the counter. That makes sense. And if you are So I think I need to know when the vertical counter is being added. And I need to use this one because I'm adding maybe too many. I'm adding too many. Why? Print adding. Oh god. There. That's not what I want then. I want it here. INJ to know exactly when I'm adding stuff. Okay. So 4, 5, which is 3, 4. 3, 4. Wait. Oh no, 4, 15. 4, 14. Wait, what? That can't be right. Oh, maybe it refers to this. Doesn't do padding on here. Oh, never mind. Obviously, arrays are next. Okay, that one is correct. And then the 5, 8. 2, 3, 4, 5, 6, 7, 8. Alright, so after, not that long actually, I think I might have figured it out. We can't increment on northeast, because think about it. If you're on an L, in an L, which is northeast, you can open there, right? That's like an opening, but you can't increment a vertical counter there, because you need to wait for the closing, the west, to come in. I think this may give me the right answer now. That gives me 8 on this kind of hard example. Alright, let's check with this easy one. That should give me 4. That gives me 4. Okay, hopeful. Hopeful, very hopeful. 40. Seems very low. Oh, no, man. I really was hoping that was it. Okay, let's go through this one here. Any tile that isn't part of the main loop can count as being enclosed by the loop. Yeah, this one is just really hard. Oh, that only gives me 1. That's good though. Means I can check some more stuff. That wasn't quite right. What does this say? Any tile that isn't part of the main loop can count as being enclosed by the loop. Here's another example with many bits of junk pipe lying around that aren't connected to the main loop at all. Wait, what is this? Like, a lot of junk tiles. So, left J, no, we have a 7. Wait, what? That can be enclosed by the loop? That's okay. So the junk can also be included in the loop. Right. That must have been it. So that must have been it. Basically this here then isn't really what I want. So I think, oh, okay, here's what I will do. If it isn't empty, then we'll ask if map.get. We're gonna take E, and that's gonna be J. Get E. It exists. Continues basically. If it's not empty and is in the loop, we continue. Otherwise, we keep going. 10. That is right. Oh, come on. Go on. John wants to go to sleep. No. Oh, come on. Alright, let's check. Maybe we broke this example here. Let's check. No, that's 4. This should be 8. That's not very reassuring. That's 10. The thing is that off by ones are probably likely. So what I'm going to check is what I set the start to. Print start as a char. Not equal to start, but regular start. J, is that right? Yep. Did that give me a different answer? Yep, okay. Good, that was an easy fix. Wow. My brain wasn't working and it was a pretty hard problem. And yeah, that was actually really tricky for part 2. It took me a lot of doodles on a notebook to figure out what the hell was going on. But we got there in the end. Yeah, cool. Wow, still going. I'm proud. I'm proud. So far so hanging on in there. But okay, thank you so much for watching. I'll see you tomorrow.